Hello, everyone. Welcome, everyone. My name is Elisa, and I will be today's host. Today's ESW talks is going to be given by Sarah Barr Engel. Sarah Barr Engel is a solar development engineer at EDF Renewables. She will be discussing the importance of a multidisciplinary approach to climate change solutions, especially the energy transition, and why we need to think about energy, transportation, infrastructure, water, etc. as interconnected systems, not only as individual issues and solutions. Sarah, take it away.
Thank you so much, Elisa. I'm just going to share my screen. Oh, how do I get into full screen mode? Can you guys see just my screen or all of the stuff around it? There we go.
Yeah, now I can see it.
Perfect. Okay. So as Elisa said, I'm going to talk about climate change solutions from a multidisciplinary approach. Most of this is just my perspectives and observations based off of roles that I've had in the industry and in working towards climate solutions, as well as things I've learned in my studies. So a little bit about me. When I was in high school figuring out what I wanted to do as I was looking at colleges, I came across the idea of studying environmental engineering, mostly because I had been thinking about engineering for a little bit, and I knew that I liked math and science and problem solving and some of the intro engineering classes I had taken. But I also knew that I wanted to work towards solving climate change. I wanted to be involved in sustainability. That was something that I've been passionate about for a while. And so I figured this was going to be the best way for me to put those things together. The very naive high school Sarah thought this was going to be very straightforward. I was going to be designing new wind and solar technology, as if that is exactly what environmental engineers do, or as if those were still very new fields that had, a ton of work to do in them. And I actually really liked my environmental engineering studies. I was at Cornell, and it's a great department, but it's very water and wastewater focused. Also soil, bioremediation, things like that. And as I was reading more and learning about, the issues and who was contributing to global warming and who was emitting the most and where we might have to start. And also as I was taking classes in different things, I realized that I really wanted to be in renewable energy. Luckily, I was able to take 1 or 2 classes in that, including a material science course, which was really interesting in learning more of the in-depths about photovoltaics. And I was also really lucky to be a part of ESW for my 4 years at Cornell. And that was where I think I gained the most experience during my undergrad with energy, working on a bike charger and a small scale wind turbine, and also seeing what other people were doing in other projects with solar ovens and solar pressure cookers. There were just some really, really cool work, and there was a lot more creativity in the possibilities of what we could do in the energy world than what I saw in water and wastewater. And I also was lucky to have the opportunity to study sustainable development in Copenhagen for a study abroad. And I spent 4 months there in a program that really valued hands-on learning. And that meant exploring neighborhoods and seeing, what they were doing firsthand with biking infrastructure and biking to class every day, and in solar panels kind of built into buildings, and in having a really great public transit network, in visiting an island that is fully powered by solar and wind, and in being able to see offshore wind 10 minutes from where I was living. So that was my next kind of introduction into this. And then I also had summer internships at the American Wind Energy Association, where I learned a lot more about the people and the policy and the safety side of the wind industry, in addition to hearing about some of the cool trends. And at the Naval Research Lab, where I didn't necessarily actually assume that the work I was going to do was going to be energy related, but I actually I ended up getting to work on a microbial fuel cell, and in researching the electrochemical effect in like a specific biofilm that was helping power a pretty efficient microbial fuel cell. And it was a totally different perspective in, the types of energy systems and where we need to change things, because this was powering like remote Navy sensing devices, which obviously are not like electric grid connected and have a whole different set of like criteria and constraints. And so in knowing that I wanted to be in renewable energy, as I was finishing my undergrad, I sort of in the back of my mind knew that I wanted to do a master's that would allow me to learn more about the energy industry. But I also decided to defer that a year and work at Building Energy, which is an Italian-based renewable energy independent power producer. And in the US, they do specifically wind and solar. And this is one of those things where you kind of take what you get. And I was really excited to be in the energy industry. I was on the business development team for the year that I was there. And I think that was a really good thing for me, even though there were parts of it that were, frustrating, like reading through lease agreements. And, I definitely missed some of the like logic and the math and the more engineering side of things. And that was also very helpful in me realizing that that was something I did want to do. But I also learned so much about the energy industry that I had not learned from any of the articles I had read or the, classes I had taken. And I was lucky that part of my job was just following industry news. So keeping up with trends in technology, researching battery storage, looking at local policies across the country. And that also was really helpful because when I did start my master's at Berkeley last year, I ended up taking some classes that I never thought I would want to take, but that I thought I ended up finding A, really enjoyable, and B, really helpful in understanding how our energy systems work. And that included a law class on energy law and policy and a markets class in the business school on energy and environmental markets, in addition to courses that specifically talked about how, like the history of how humans have used energy and how different societies across the world use energy, and how that's changing and how our energy systems specifically affect communities, and, energy optimization modeling, how does a grid, like a ISO and RTO, like determine what generation is going to be dispatched at different times, as well as just more details on how our transmission and distribution systems work. And I have no regrets in spending a year doing a master's in this because it was fascinating and had a ton of interesting conversations. Also got to talk a lot more about, how we evaluate different solutions. And it was fun because I had classmates who, like me, were interested in energy, but also classmates who were interested in sustainable aviation and in building energy, like how, we make our buildings more efficient and things like that. So it was a really great, very condensed year of just a lot of learning and a lot of expanding my ideas about what was possible in the realm of climate solutions and what would be needed. And that brings me to the present. So I'm currently working on early stage solar projects, mostly between 1 megawatt and 20, although sometimes out of that realm. And I get to work on the original design as well as production estimates for how much power we think these projects are going to produce. And I'm in a part of the company where I'm doing engineering work, but I'm mostly interfacing with our business development team who are, looking at potential sites or responding to requests for proposals from utilities or from companies that want to reduce their footprint. And so that leads to a lot of interesting conversations about, what types of projects can, be economically feasible, what design criteria are needed for different types of projects, how that changes depending on if you're in New York or Texas or, Wisconsin, because each of those has a different interconnection system and has different local incentives and just different they're at different stages of increasing their renewables, and so that completely changes sometimes how we look at a project, and that's been a lot of fun. And it's generally very exciting to be able to take a step back and realize that you are actually doing the work that you've wanted to do for a while. So all of this is to say that there are many ways that we're going to need to look at the climate crisis, lots of aspects, lots of contributors to climate change, and lots of possible solutions, but not, as mutually exclusive climate solutions as additive climate solutions. So you might have some background in this, but just in case, I'm going to go over the biggest contributors to climate change. The first one is fossil fuels. The most recent data I found was from 2019, and that was emissions from burning fossil fuels accounted for 1/3 of all greenhouse gas emissions. And I just want to say that this is global versus US specific. The second is transportation, and that includes cars and trucks and airplanes and ships, our whole transportation network. And that individual transportation as well as the logistics of transporting products across our world. And then manufacturing is a huge contributor to climate change, mostly because big industry is very energy intensive and energy is mostly fossil fuels. And then you get into agriculture and food production, and that contributes to climate change in multiple ways, partially because of the practices that have led our soils to be less efficient at sequestering carbon, but also in methane emissions from cows, and the fact that we have big agricultural food production companies that it's factory farming, so that there are big warehouses and shipping and all of the things that you think of as manufacturing also apply to a lot of our food process, and processing of foods can be very energy and water intensive, as well as growing, and as well as pesticides and fertilizers and other things that can contribute different types of greenhouse gases. The next big contributor to climate change is deforestation. That happens for a variety of industries, logging and, clear cutting area for growing other types of trees like palm oil, clearing land for farming, clearing land for paper, or clearing trees to use for paper and paper products. And that has two issues. One, a lot of times we use slash and burn farming, and burning anything is going to add CO2 to the atmosphere. But trees also happen to be really helpful in our planet's natural ability to take carbon from the atmosphere. And so it kind of has a twofold effect there. And then the last two are burning wood or biomass for heating and cooking, as well as methane produced from landfills. So some of the needed changes, and this is kind of in direct response to these specific areas. But I want to note that this is not exhaustive in the slightest. So we're going to have to transition to 100% renewable energy. This is completely a given, and it's one of the areas that we've actually, I think, come the farthest on in many ways. We're going to need more public transit and car sharing, and just generally reducing the amount of like driving that we're doing. Also low carbon jet fuel and bunker fuel, shipping and like airplane fuel happen to be way worse than the fuel that we put in our cars. And transitioning vehicles to electric vehicles and hydrogen fuel cell vehicles, etc. And then in the manufacturing industry, really the best we can do is less energy intensive processes, but then also once we're at renewable energy, that will cut manufacturing emissions significantly. And then also some of the like resource extraction processes have their own emissions associated with them. And so generally using less and manufacturing less will be very helpful. Eating less meat and regenerative farming practices that really help keep our soils healthy and make sure that we can actively sequester carbon in our soils versus releasing it every time we want to replant. Stopping deforestation, very big one, as well as planting more trees and making sure that we are ecologically focused and making sure that we're planting the right types of trees in the right types of places. Switching to solar or electric ovens and having a more circular economy so we just generally produce less waste. And now I just threw a lot of ideas at you. This is just a small subset of what we're going to have to do in order to I don't want to say solve the climate crisis because we're already a little bit past that, but generally minimize the harms of the climate crisis and get to a stable, sustainable place. So there are multiple ways to approach this. And some of the classic thinking is very siloed and very narrow. And especially if you've heard of like triple bottom line or the 3 pillars of sustainability, this became big maybe 5-6 years ago, where we talk about sustainable as being sustainable for the planet, sustainable for people, and sustainable for the economy. And when people started talking about this idea of holistic sustainability and how we have to make sure that, the solutions we're looking at work for, all of these factors, there was a huge amount of pushback that said, and from the environmental community especially, saying like, if we're looking at all these other things and not just focusing on environmental sustainability, we're not going to be able to get anything done and we're going to lose focus and that's going to get in the way. So like, we just need to focus on the planet. But obviously our world doesn't exactly work that way. And that's how you end up bumping into, policy issues and people saying, oh, we think that's good, but this is cheaper. And then there's also the idea that, every industry can tackle their own problems. So, we can work on better renewable energy technology that will compete with fossil fuels. And we can think about just that section of it. Or farmers can work on their own agricultural processes and they don't have to worry about the amount of water they're using or the energy that's it's taking to process certain things or anything like that. But obviously there's, you can tell just from the way I'm talking about this, this is not the best way to think about this because we live in a very interconnected world and all of these aspects and all of these issues that are causing climate change are interconnected. So if we think about climate systems and we completely simplify this and just think of the water, energy, food nexus, right? When you think of water systems, especially in the US, can be very energy intensive. One of the things I learned when I was studying in California, because everything example-wise was skewed towards California, was just I don't remember the exact number, but it's a very high percentage of what the energy use for the state is that comes from pumping water from the north to the central and south areas of California, which are more dry. And that is for like drinking water, that's for irrigation, that's for industry, etc. And so, you know, when you think about water systems, they're always going to be intertwined with energy systems. And then you also have, you know, dams, like competing dams for hydro and irrigation. One of the reasons that we're unlikely to see an increase in hydropower generation, even though it's a pretty great source of renewable energy, is because most of the like places where we could put dams to build hydro at large scales are already dammed, but the water control and the dam control is specifically for irrigation. And that is unlikely to budge right now. And then you also talk about the amount of water that is used in different types of energy production. So when people like, now most of the time people hear solar and they think solar photovoltaics, but solar thermal has also been a pretty big source of solar energy, and specifically like solar water heaters. And that is basically using the solar energy to heat up water and then like run water through a system for heat, or to like create steam to run the turbine. And then in talking about irrigation, I already talked about kind of the overlaps with water and with food. And then with the overlaps between energy and food, you know, sometimes you have trade-offs between, is this food or is this crop going to be used for food or is it going to be used for energy? And especially in the US, we have, you know, huge subsidies for corn ethanol, which means that we overproduce corn and a lot of it doesn't actually get eaten. It gets turned into biofuels. And so on top of like these intersections, you're going to have competing land use, and you're going to have added air pollution. Like this doesn't even talk about, you know, right, you have greenhouse gases, but then you also have ozone depleting gases and like different toxins in the air that can like harm human health. We have the need to make sure that we have safe drinking water. So when we talk about water processes being energy intensive, we don't want to just completely get rid of some of these water processes. Like they can be very important for human health and for making sure that we all have safe water to drink because we're treating our water. And then on top of that, we have all of, you know, all of these competing, you know, areas that directly impact the climate. But when we start talking about solutions, it's really important to keep in mind who works in each of these industries that we're trying to change and how are they going to be affected and who benefits from the changes and who gets harmed from these changes. And then on top of that, there, you know, the people who have the power to make the decisions in a lot of these trade-offs are not necessarily people who are directly impacted. And wow, that is a lot to think about when you're trying to, you know, create change that ideally benefits everyone, but has all of these other nuances and trade-offs that go along with it. And so I've put together a list from thinking about these systems and from kind of what I've taken from a variety of different classes and jobs to say, you know, here are some really important perspectives that we need at the table when we're thinking of climate change solutions. So the first is the earth and atmospheric scientists and people who really understand, you know, how each type of emission impacts our climate and impacts our water systems and, you know, impacts human health and what parts of these things are natural and what parts we are producing from human impacts. And then we need people who understand the technology, mostly engineers, and being able to analyze what needs to change about old technology and what we can build to replace it or to improve it. And this is especially true in the energy industry, but this is also true when we think about technology that has improved our farming practices and technology that has allowed us to better, you know, sanitize our wastewater and things that overlap where we can, you know, produce energy from wastewater. And this includes things like carbon capture and sequestration, where you know, in the short term, while there are still coal and oil plants and refineries that, you know, are not going to close overnight, how can we make sure that they are polluting less? Those types of things. And then we need like psychology and sociology and like behavioral economists and people who understand like how do we, and people who like are looking at communities and being able to answer questions like who is most affected by polluting industries. For example, like Blacks and Latinx people and low-income people are generally more likely to live near like coal and gas plants and heavy industry, and are more likely to be affected by air pollution. And a lot of that is interconnected with like former housing policy and discriminatory practices by banks based off of like where they were able to live. And also from like people in those industries saying, oh, we can build there because we know that those people are less likely to protest or less likely to have people in local government who are sympathetic to their needs. And, you know, when we're thinking about solutions, we have to make sure that we're taking all of these perspectives into account and making sure that, you know, everyone benefits from this transition, but also knowing how to get everyone on board with these types of changes and make sure that they're seen as opportunities and not as, you know, burdens. And so that's where some of this like sociology, psychology also comes in. Like, how do we incentivize this at an individual level, at a corporate level? And then the policy side, how do we incentivize this from the top down? And that can be, you know, incentivizing better practices like through a carbon tax, or banning harmful practices outright, or, you know, just creating funds that are meant to only go to climate solutions. And obviously this is not an easy thing. That's why the Green New Deal is like in outline and has absolutely zero like specifics. But, you know, as much as it would be great to say like, yes, we can all do this, like from an individual perspective, we do need that top-down incentive if we want this to happen as quickly as we want it to happen. And then the last thing on here I think is very important, and that's communications. And I think that's something that has been lacking, especially from the scientific and engineering communities, where, you know, the people who understand the science of it and the details of these technologies have not necessarily done a good job communicating, you know, why this is important or how this affects people specifically. And I think something that we've seen more recently is better communications around like how, and also partially spurred by the fact that like more people are being affected by climate change as it accelerates, but just doing a better job of communicating that climate change is not some like abstract, like invisible idea, but is actually like specifically wildfires that, you know, cause people to move, or floods or hurricanes, or, you know, these very tangible things that specifically and directly impact people and communities. And that is how people tend to connect to these issues and to really develop a sense of urgency and a sense of like action. And I think having more people in the like climate and sustainability space who are good communicators and storytellers is very important. And so just to give a few more examples from things that I've, you know, interacted with over the years of where, you know, it's really important to have different ideas and different backgrounds of people in the room discussing these things. One of the things that I thought was really interesting, and that unless I was working in this specific internship, probably would not have heard about. But I was in the Office of Safety and Standards, I think was what it was called, at OEA. And one of the things I worked on was an RFP for a study on wind turbine ergonomics. And, you know, when you're looking at fluid mechanics or, you know, the power equations of like how wind turbines work, or you're looking at the like implementation of it, there's very little discussion of like how it impacts people. There's a discussion of the noise, of, you know, the impact on birds, of, you know, the costs. But one of the things that we talked about was the people who are doing maintenance and like checking in on these wind turbines. Like, these are really tall wind turbines, and it generally requires somebody climbing a very tall ladder with a lot of equipment to then like squeeze into this tight space at the top of the nacelle. And that can be very harmful for like people's like back and general like muscles. And I clearly did not retain enough information on ergonomics, but the idea was that this was a totally new perspective on like what we can do in the design of a wind turbine that has nothing to do with the energy output, but solely has to do with how we design some of the internal structure, like having a pulley system next to the ladder so that you don't have to climb up with your equipment belt on, or in changing the layout of, you know, where the generator versus the inverter, et cetera, is in the nacelle to make it easier for people to navigate and to, you know, see what they're working on, and therefore they're less likely to get hurt. And so I just thought that this was a really great perspective of, you know, all of the different ways climate solutions can impact people and communities, and, you know, why we need to have multiple people influencing the solutions and the technology, and advocating for these types of changes. And then both at Building Energy and at EDF, I have noticed that state incentives greatly change the economics of solar and wind projects. And it all, like, state incentives, but also like federal incentives, you know, we change basically when you buy solar panels and other like technology associated with the solar industry. And there's a slightly separate way that this happens with wind, but there's the investment tax credit. Oh, sorry. And that means that the company gets a tax credit like based off of the amount they procure. And that is slowly stepping down since it was enacted. And therefore solar panels that were bought, you know, a few years ago have higher tax credits associated with them than solar panels that are being bought now. And therefore but those also tend to be the less efficient panels because technology is improving. And so there's always a balance of, you know, what panels we use for this project based off of other incentives and other economic factors of how well they're going to pencil. Sometimes it's based off of the different market it's going into. And if you're selling like on the wholesale market versus like to a direct customer, that can change. And then if there are other like incentives that are directly coming from the state or from a local jurisdiction that make it an easier permitting process, or that require utilities to increase the number of renewable energy projects that they're including. All of those things can make or break a project, and also can affect where more projects are being built. For example, like New York State has been one of the best places to do renewable energy projects for the past however many years. And it's now actually becoming a little bit more difficult because there's so many, like especially like solar projects, that the interconnection queues can't take any more capacity. Like the transmission lines like physically can't take more generation, or can't take like bigger projects in specific areas. And like, yes, there are ways to change that and to build out our transmission infrastructure, which will also help make our grid more reliable. But like in the near term, like that is actually now a concern of like, oh, this is too good of a place to do solar and wind. Whereas there are a lot of places in the country where like, you know, they could really benefit from more renewable energy projects, but the economics aren't great. And therefore you don't see as many projects. And then a totally separate example was the biking infrastructure in Copenhagen. We actually got to have one of the former mayors, although they have multiple different mayors, so this was like specifically a mayor on climate change kind of work, come talk to our class about this initiative that he did on increasing biking infrastructure. And Copenhagen now is seen as like a huge bike city, similar to Amsterdam, but that was actually a relatively recent change, like in the past 15, 20 years. And part of that was because this mayor specifically had this idea, which was we need to invest in biking infrastructure. We need bike lanes everywhere, bike traffic lights, like we need to time lights so that it's easier and faster to bike into the city. They clear snow on bike lanes before they cleared on roads. Like all of these things that have been put into place that make it so that like even if you live in some of the farther suburbs of the city, it is faster to bike into the city than it is to drive. And it's easier to bike into the city than it is to drive. And you can also take bikes on like trains and on metro and like specific cars that have like spaces for bikes and like places bikes can clip in so that it's not just like you're on a crowded metro car and you happen to like be trying to navigate your bike around. And he got a ton of pushback when he first proposed this because, as I said, Copenhagen was not a biking city. And there was a lot of worry that they were going to spend a lot of money and, you know, spend a lot of time on this policy that, you know, were people really going to use it? Were people really going to need it? But what this mayor knew was the concept of induced demand, where if you build it, if you build the infrastructure and you make it easier for people to do one thing over the other, and you incentivize one practice versus another, more people are going to follow suit. And therefore, this huge infrastructure project actually led to a significant increase in the percentage of people who bike and who use biking as their main form of transportation. And I just thought that that was like a really great idea, and like is such an important way to think about future policies as being like proactive versus just retroactive of like, oh, look, there's this issue, let's solve it. But like, let's think about what's possible and figure out how to incentivize it. And then I already talked a little bit about energy and climate justice, but those are areas where there are so many pieces that come into play where, you know, it's about people and communities and policies and industry, and there's a lot of change that's going to be needed and a lot of coordinated change that's going to be needed in order to make sure that not only are we building a sustainable like economy, but that we're building it in a way that everyone can benefit. And there are two, I think, pretty good multi-industry approaches that will be needed kind of no matter what part of the solution we're talking about. And the first one is life cycle analysis or life cycle assessment. And this is not a very complicated idea, although some of the software and the ways that we actually go about calculating like, you know, life cycle emissions can be pretty complicated. But the idea is to look at a product or process and look at every single stage from resource extraction through the manufacturing process, through the construction process, through the logistics and distribution and transportation of that product, to how people use it, to its end of life and how it's disposed of. And that takes into account all of the resources as well as any waste and byproducts, and really looks at especially the greenhouse gas emissions, but also sometimes like other air pollution and energy use and water use at each stage. Because it's very easy to say like, oh, you know, this specific thing is relatively sustainable based off of, you know, maybe the materials that it's made of, they're renewable, regenerative, etc. But there's a chance that it was, you know, built really far away in a very energy intensive process, and therefore is it really that sustainable? This gives a good lens to which we can view multiple different types of things kind of from the same baseline. And one example of that was from a research project I did last year, where we looked at the life cycle impacts from a solar photovoltaic plant, which is like the classic solar panels, and from a concentrated solar thermal plant, which uses a series of mirrors to reflect light to a solar concentrator, which gets really hot and creates steam and spins a turbine, producing electricity. And we looked at 2 plants in similar locations and similar climates of similar size. And you can see here that like the data we had for each was not exactly the same. For the PV manufacturing and construction, based off of some of the sources we were using, got lumped together. But you can see that when you're just looking at greenhouse gas emissions, concentrated solar plants are lower emissions, and that it's a little bit more evenly distributed as to where that comes from, whereas photovoltaics have higher like greenhouse gas emissions, and most of that is in the manufacturing and construction phase before you even use them. But then if you're in a place, for example, where concentrated solar is most common, which is, you know, big areas of the desert, like in California or Arizona or Chile, those are where some of the biggest ones are, it can be a huge issue because they use a lot of water based off of the fact that you are using water to create steam in this process. And then you also have cooling mechanisms at different parts of it, and you have to wash the mirrors. And so, you know, if you were to only look at the greenhouse gas emissions, you might say like photovoltaics are not as good, like we should be doing more concentrated solar. But then when you look at where concentrated solar is and the water footprint that it has, it's understandable why most of the projects that we actually see are photovoltaic. Yeah, I think that was all I had to say on that. But just a really great approach and great way of thinking about things that gives you a framework for looking at the impacts on the environment from different technologies and different processes. And then the second one is the idea of circular economy. And essentially, if you come back here and you look at the process from extraction to disposal, that is a very linear process. And that assumes that we're going to continuously extract more resources and then throw them away at the end of life. And the whole idea of circular economy is to close that loop. And this can work ideally with any industry and any process where instead of saying, okay, we have these waste products, we look at, okay, can we make things so that they're meant to be repaired instead of like broken and thrown away? Can we make things so that they can be reused or upcycled? Can we make things that are, can we prioritize a recycling industry that actually, values recycled materials and makes the case for, recycling things instead of just like throwing them away? And it also, there's a lot of interesting resource sharing ideas where, I don't remember exactly where, but there was an example that we learned in one of my classes where a whole bunch of different manufacturing plants got together in this like industry park, and they're all close enough and have like connected pipelines between the buildings where, this plant creates, chemical X as a byproduct that this, plant B needs. And so instead of like just having a byproduct that actually gets used by this other process. And I'm sorry that that's a little bit vague. I should have looked up that example beforehand, but I just thought about it. But the whole idea about this is taking, the same types of systems that we have and just figuring out how to put them together in a way or to better support or redesign in a way that like we can still use similar things, but make sure that we're not, creating things to be thrown away, or that we're better taking care of what we have, or looking at processes where we can continuously reuse the same materials, and therefore we have less resource extraction and less waste. And so all of that is to say, everyone listening to this and, everyone who is interested in being part of the solution, and even if like, that's not your biggest passion, like everyone is going to be needed in order to solve this climate crisis. And if you are especially interested in this, like, don't stress too much about, you know, okay, like I need to be this type of engineer, or I need to study X, or like I have to start working, you know, at the top at like this type of policy level. Like, you don't have to fit any specific mold to work towards climate solutions. And I think the best thing is for everyone to find what they're passionate about, and then find the overlaps between that type of work and, you know, how to, and climate, and figuring out like, okay, if you're in this type of industry, how do you improve this type of industry? Or if you are doing this type of work, how do you apply it to areas that need help increasing their or decreasing their carbon footprint? And if you're interested in figuring out like relevant jobs, there is a huge wide range of possibilities, and that can be very overwhelming. I applied to so many different types of jobs in solar and wind and like analysis, like, you know, consulting kind of positions. And I applied to a climate change office at a local government, and a job that was looking at life cycle analysis of steel, which was like the steel industry group. And I think the idea was like, you know, I have this skill set and I want to make this kind of change. And, you know, here are all the ways I can do that. And so obviously you don't want to make more work for yourself. And it can be very disheartening when you start to like search for things, and like when you like talk about environmental positions, sometimes that's like environmental health and safety. And you get all of these things that like have the word environment in them, but have nothing to do with like the earth or climate environments. It has to do with like working conditions. Or you're looking for, you know, energy jobs, and a lot of the jobs in solar that come up are for people who are doing sales of, you know, like how do we connect to customers and say like, do you want to put solar on your roof? Which is a really important job, but happened to not be what I personally was interested in doing. But, you know, finding those filters can be difficult. And so I think one of the best things you can do is network. You're luckily part of the ESW network, which is fabulous. We have, you know, a job section on our Slack. We sometimes post jobs. It's a great group of people just to talk to, and to talk to alumni and see like, okay, what are people working on? They're also, you know, there's a group called Green Drinks, that there's like Green Drinks DC and Green Drinks New York and things like that. And they do like happy hours for people in the industry. So those are currently, I think I saw something about a virtual one, but like in general, like once those types of things like become more regular, those are great ways to meet people and to talk about the type of work that people do. And then also looking at like industry groups who will post different opportunities. One that I follow that has been very helpful is RISE, which is Women in Renewables and something, but essentially it's Women in Renewables. And they have a lot of career postings on their LinkedIn. And then OEA for wind and SIA for solar will also post opportunities. And if you're not sure what types of things are available or what type of work you want to do, or you read a job description and you don't really know what that means for the day-to-day, doing informational interviews with people, I think, is very helpful. I did that. My uncle works in the aviation side of a large consulting company, but he knew some of the people in their sustainability side, and he connected me. And it was helpful just to be able to say like, okay, like you are an energy analyst or a climate solutions analyst. Like, what does that mean? What type of work do you do? What types of projects do you work on? Or, you know, getting to go to panels where you hear people who are in the energy industry in a variety of different roles talk about the type of work they do. I think there's, especially in the way our education system is, like we learn a lot of like facts and skills, but we don't really learn like all of their applications. And therefore, when you actually start looking for jobs, it's hard to know like what a title actually means for the type of work you're going to be doing and the type of change that you can create. And then another really great resource is Ed Crowley's Clean Energy and Sustainability Jobs List. He sends a weekly newsletter, which also includes like articles that he finds interesting. but happens to be like things that are related to sustainability and renewable energy from a variety of different perspectives. So there are a fair number of policy positions and like industry analysis kind of positions and like activism kind of groups and like writing, communications, and energy, and like it's a good mix. So I think that's a good place to start. And then also Day Away Careers is a clean energy jobs platform, and not to purposely cross plug too much here, but one of the previous ESW talks was Mike, who works there, and you can find his ESW talk where he answers a lot of questions about like how to get into the clean energy world on the ESW YouTube channel. And then I think the best thing you can do is to just constantly be learning about different types of solutions and different areas of the like climate world, and different industries. And I think the times that I am most optimistic and most hopeful about like our ability as a society to like actually get this done is when I'm reading about like people doing really cool work in this, even if like it's not always the norm, or you frequently hear more about like the bad news and the, you know, increased hurricanes and the destruction or the lack of action from our government or things like that. So Green Tech Media, I should put Green Tech Media on there. Green Tech Media is a really great like reporting like news outlet for industry news. And they host 2 podcasts, The Energy Gang and The Interchange. And they do like very good deep dives on like very specific technology trends, which if that is your thing, like I mean, I personally find it helpful just to like know what's going on in the world of renewable energy. And I think some of it can be more approachable than others, but it's a good place to start. And there's also a podcast called How to Save a Planet. And the 2 co-hosts, one is Alex Blumberg, who is most known for Planet Money. And so that's his like podcasting expertise and research expertise that comes in on that side. And then the other is Ayanna Elizabeth Johnson, who is a like marine oceanographer. She's like a scientist by training and by profession, but has also done a lot of work in the nonprofit space and in the policy space. And she helped like advise Elizabeth Warren's campaign on their climate policies. And the way the podcast is set up is that they do like deep dives onto different aspects of climate solutions. And, you know, they range from like how a small coal town is pivoting to renewable, like to offshore wind, to, you know, how fossil fuel money like contributed to the Republicans being a party of climate deniers, and like how that's changed and the people who are trying to like change that back. There was a whole episode devoted to wildfires and why they've become more destructive and why they've, you know, like how we've changed our wildfire management practices and how we live in different types of communities and like all of that kind of stuff. It's fabulous. I highly recommend. And then, you know, reading books that are also solutions oriented. I read enough passages from Reinventing Fire for one of my classes that I actually bought the whole book. And it's by one of the main authors is Amory Lovins, who was a pioneer of the like soft power path compared to the hard power path, which prioritizes like energy efficiency and distributed energy solutions. And it just goes into a lot of depth about the like specifics and the types of like economics and policy specifically that are associated with solutions in the energy space and like decarbonizing our electricity grid and in transportation and in buildings. And it's just very comprehensive and like it's a lot of information, but it's very digestible. And then like Vox and Washington Post like both have climate sections where they do a lot of like detailed analysis and reporting on solutions. If you want to learn more about LCA approach, the EIO LCA platform is a free way to like get LCA like assessments of different products and industries. And if you want to learn more about how all of these different climate solutions affect people and the like intersectional approach to environmental activism, Intersectional Environmentalist is a fabulous platform for that. And so generally, closing thoughts, this will take everyone, this will require things at an individual level, a corporate level, federal level, lots of like perspectives, and therefore everyone has a role to play. And I think it's very important to just expand our ideas of like what a climate solution is, and continue to be creative and ambitious and push for change, and stay optimistic. Oh, sorry about that. So if anyone has any questions, I know that that was a lot of information, and not a lot of specifics, but I'd love to hear your thoughts.
Yeah, Sarah, thank you so much for that. That was awesome. You know, it's kind of difficult sometimes to draw the connections between just like how vast climate change is and how many different things it touches. So really appreciate you tying so many different aspects together. I think I at least was writing down stuff to look up later. So anyone have any questions or any points of discussion that they'd like to share? Well, we can marinate on it a little.
Yep. And if you're in the ESW network, you can always message me on Slack if you have questions that come up later.
Awesome. Okay. Well, in that case, Sarah, thank you so much again for your time and for putting together such an awesome presentation. You know, I know that takes effort to prepare too. Really appreciate it. And thank you everyone for attending. We're grateful for, you know, your participation. So have a great evening and we hope to see you all next week.
Thank you so much.
Thanks. Bye.
Thanks, Sarah. Great presentation.
Thanks, Sarah. Great job.
Thank you. Thanks, guys. Have a good evening.
Great job, Sarah.